We're going to be talking today about design patterns. I have a little quote here for you to start off with. Each pattern describes a problem which occurs over and over again in our environment, and then describes the core of the solution to what the problem is, in such a way that you can use the solution a million times over without ever having to do the same thing twice. This quote is from Christopher Alexander. He was a well-published architect and town planner who's also been quoted in the Design Patterns, Elements of Reuse Object-Oriented Software, which was a book that I read in when I was at university. This book was also made famous by Grady Booch, who was the chief scientist at Rational Software Corporation, who is also known as the godfather of object-oriented software design. So design patterns are very important in the sort of development world. And we're going to look at a few today. I've put together some samples for batch processing, changed data capture, state-based calculations, transactional loading, loops, and we'll talk a bit about pre- and post-processing in relation to some of the ETLs that I've built here. Now we're going to structure this in such a way that we're going to define what the problem is that we're trying to solve first in the pattern. So the problem that we're trying to resolve in this first pattern, which is batching, is how can we define when something has been inserted or updated into our systems, and how can we roll back at any point in time to the previous values. The solution to do this is to get some sort of unique identifier and attach that to the input stream for the data, and use that when you do your updates to the database. So as you can see on my screen, I've got a very simple ETL process sitting here. Now what this ETL does is it goes into the system, loads up a text file, gets a batch ID, and then writes out a text file. So we'll just go through the steps of what I did to create this. So first and foremost, I just did the simple text file input step, and I dragged that across onto the desktop. And the configuration that I put in here was to select the sales data sample file. This is actually a standard Pentaho file that you can find in any of the BI installations in the data directory. So I've just grabbed that file as some sample data and enabled it to be used in this report. Oh, sorry, ETL. Once you've actually got the ETL, you come onto the context page, and the important thing here is that the actual file, if we do a preview, is comma delimited. So the default in Pentaho is actually a semicolon. So you've got to make sure you change that, otherwise you're going to end up with not much useful information. So we'll just change that back to a comma. Once you've got your fields, once you've put that comma in, you can come onto the Fields tab, hit the Get Fields feature, and that will populate all your metadata and fields for you automatically. The next part of the exercise is to somehow get a batch ID. Now there's lots and lots of different ways to approach this. One of the common ways is to create a batch table and use that batch table as to get a unique batch ID and to usually put some statistics in against that batch, like when it started, when it finished, maybe how many rows it processed, etc. In Kettle, or PDI, whichever way you want to call it, in Kettle, there is the ability to log to a database. If you turn that feature on, it automatically generates a batch logging system for you. So I'm just going to click on the Show Panels button here, and what we should be able to see is if I go to Execution History and click on there, we'll hit Refresh, and we can see that I've run 52 ETL jobs. Now that's not this job 52 times, that's just 52 ETL jobs to this logging table. So I'm going to utilize the unique batch ID that is created in this table for the purpose of the batch processing in this job. To do that, I've used the Get System Info step. Just turn that off. So that's the step there. You just drag that across to your palette. And once you open that up, I've defined my variable name as batch ID. And when you come in here, you've got a multitude of different types of variables that you can select from. The one that we're interested in is the job batch ID, transformation batch ID. So you can get either the batch ID for the individual transformation, or you can get the parent job batch ID. So if you had this transformation being ran inside of a larger job, you could actually have the transformation and the records all linked to the one batch ID for the job rather than individual batch IDs for each transformation. So we're going to leave it at the transformation batch ID. The next step is just a very, very simple database output. We're outputting to a table that I've called stage sales. So that's a staging table that we're going to use for our sales data in some following steps. I've got it to truncate the table, which is very common when you're actually loading staging tables. The other one that I like to do is to tick on the specify database fields, and then I can come into this database field tab and populate the fields as I like. You can speed up the process by clicking on the Get Fields button, and that will bring in all the fields. Now, once you've actually built a table, if you're building from scratch, one of the nice features that Pentaho has is you've got an SQL button down here. So if the table didn't already exist, like in this example, it's going to try and create the table for us based on the metadata that has come in from the previous steps. So if I execute that, it's executed the statement successfully, and I've now got a table at my back end. So if I come into our view table, databases, and sample data, sorry, I didn't sort of indicate that, so it's in the sample data connection. And you can right click on sample data and go to explore, and that will bring up a dialog where I can actually scroll down and I will find my stage sales table, and of course it's going to have nothing in there. All right, so let's execute this job. So if we hit play and just straight out launch it. So it's a very fast transformation. There's not a lot of records that are coming in. If you have a look at the execution results, you can see that there's 2,000 records read into the stream. and they've been sent to the batch ID, which is written 2,000 odd records to the stream as well, or updated 2,000 records in the stream, and then it's output those 2,823 records back to the database. So we should now be able to come in here, right-click on Sample Data, go to Explore, Tables, Stage, Preview 100, and you can now see that we've got the data in here. Now, the important part with the batching is this last column, of course. We can see that the batch ID has been assigned to 53. Now, when we come back and have a look in our transaction history, do a refresh, we can see that we've got a batch ID of 53. Now, there's some very interesting things that you can do with batching inside of Pentaho. What I'm going to do is I'm just going to clear my history, so I don't have a single row anymore. I'm going to hit play again and just launch it. Hit refresh. Now I've got record number 0. Now the interesting thing about record number 0 is its date range start and date range end. So the date range end is effectively when the job started. The date range start is either the date range of when the previous job started, or the 1st of the 1st 1900. This can be very useful because you can utilize that for doing delta loading, which is another common pattern which we're not going to go into today. Okay. So the next pattern that we're going to look at is change data capture. Now, change data capture, the concept that we have here is we've got 2 streams of data. Firstly, we've got our stream, which is our fact table. So this is the table that we've already previously loaded. Then we actually have the staging table. The staging table is the one that we loaded during that batch processing step. And what it's going to do is it's going to use this merge row diff to actually find out where the differences between the 2 data sets is, and allow us to process them separately. So if we have a look at what I've built here, we can come in here. I've got a very simple select statement to select the values that are coming in from my sample data, my sales table. Now, importantly on here, I've decided to exclude the batch ID. The reason for that is the batch ID would cause there to be a difference every time we were looking at the change data process. I'll cancel there. The next one is to come in here, and we're just getting the same data but from the staging sales table. Importantly, when we go down to the merge rows job, we've got to ensure that the columns are all exactly the same. There's the same number of columns, and they've got to be of the same data types. Otherwise, you'll get errors during your compare steps. So in here, my reference rows are my sales fact table. So this is the table that we want to populate from the data coming in from our staging table. And then our compare rows are the rows coming in from the CSV file that we just loaded into our staging table. We're going to do our comparison on 2 of the fields. Firstly, order number, and then order line number. We click OK there. Now, just to keep some consistency, I've included grabbing the batch ID for the transformation so that we can see which batch records have actually been updated on using this change data capture process. The next part is to add a isDeleted flag. Now this is not necessary, however the process of synchronization in the later steps will delete records if it's been deleted from the staging table and it exists in the fact table. Now in most data warehousing environments you do not want to delete any records. It's a very special case when you want to delete records from the system. So my preference is to add a isDeleted field, and that isDeleted field is very simply new field, set field from constant, and I've just put the value in as false. The next step that we're using is this case field. So in the case field, we're using the special extra field that the merge step has created for us called flag field, and we're doing a comparison against it. So we're saying that if the field comes up and it says that it's got the word change in it, we're going to go to the synchronize step. If it's been deleted, we're going to go down to the isDeleted for deleted rows, set isDeleted for deleted rows, and if it's new, we're going to do a table output. Now, as I mentioned before, the set isDeleted rows is simply modifying the flag field back to modified. Actually, that should be changed. And setting the isDeleted to true. So that will flag in the database that this row has been deleted, and the flag field will tell the synchronization step to update that field for us. So we'll go and have a look at the synchronized sales fact table. So if we have a look at this, realistically, it's the insert updates, the step that we're probably all familiar with, but they've added a couple of extra features, namely in the advanced tab where we can actually say it will look at a particular field and do an insert, an update, or a delete statement depending on what that field actually says. And that saves you from normally requiring 3 extra steps for doing this sort of changes. You can also set in here which fields are updatable and which fields aren't. So if you were using the insert functionality, you'd actually set no to certain fields. Say, for example, a created timestamp. It's something that you'd never want to change. So you'd always leave that created timestamp constant. So we'll just close out of there. Now I've chosen in this example not to use the insert step from the synchronize, but to use a table output step. The reason for that is simply because it means that we'll batch up the records to be inserted into one big block and they'll all get inserted together. Whereas the synchronization step will have a whole heap of updates and delete in there prior to and commit them in blocks separately, whereas inserts are usually faster or can be processed faster. So we're just going to go in here and I'm just going to quickly click on the Verify SQL just to make sure that there's no issues with any of our data. And according to that, there's a few columns it thinks are missing, but they don't need to be, so I'll leave that alone. We'll hit play, we'll run the job, and what we can see here is that it's executed and that the table input step has output 2,823 rows. Now, if we execute it again, that table inputs insert step shouldn't normally put any rows in that table, but looks like I changed that flag incorrectly. Good. Play, launch, yes. So we've now got our populated staging table. And that's the pattern for being able to do that. Sorry. And again, if we have a look at the execution history, just bear with me for a second. Okay. Now, we're going to have a look at, we can see that in here that we've had it all logged, and we've been getting these log IDs, etc. One of our later webinars will actually be on how to set up these logging tables. So stay tuned for that one when that comes up. I believe Diego Paz will be presenting that one for us. Okay, the next pattern that we're going to have a look at is the state-based change pattern. Now, the state-based change pattern is we're trying to find a solution for to build calculations based on states something goes through. So, for example, how long does it take between a customer placing an order and an order being shipped? In the solution, we're going to use the analytic query step to find the previous row from the sorted input. So we're going to use, again, our favorite sales data and the text file input step. Again, got it set up with comma separated rather than semicolon separated. Now, very importantly, with the analytics step that we're going to run next, it requires the data to be sorted. So I've got a sort step here, and we're going to sort it by customer name and order date. This will give us the data sorted by customer name, and importantly, we'll be able to look at the rows individually by their order date to find the previous order date for an actual field, sorry, row. Now, the analytic query step replaces some JavaScript that used to be the common way of actually doing this, and it's quite efficient. So what we're going to do is we're saying we're going to group the field by customer name, and then down in the analytic functions, we're going to create a new field called previous order date, and the subject is going to be the order date field, and we're going to look backwards by one row. So that's going to say that when we first come to a customer row, to a new customer, it's going to say, well, there's no previous order date, and it will make the previous order date null. On the next row, it will make the previous order date equal to the order date of that previous row. And here's just a reminder, the data has to be sorted to come into that feature. So I've just simply broken off this ETL to say, if the previous order date is null, then we're going to set the days since last order to 0. If the previous order date is not null, we're going to calculate the number of days between the current order and the previous order. Now, a lot of people use JavaScript at this point. My preference in particular for speed is to use Java expressions. Oh, sorry, Java calculated expression. The difference between the two is certainly speed. The Java calculated expressions can be faster than what the inbuilt expressions are in Pentaho, which are magnitude times faster than what running JavaScript would be. So I would recommend having a look into these Java calculated expressions if you haven't done it before. So we're basically doing a very simple expression here. We're getting the order date, we're getting the previous order date. Now we're getting them both as integers, and we're dividing it by, because it comes out in milliseconds, so we're dividing it up to equal a number of days. Really simple, straightforward calculation. And then we're going to spool this out to a text file. So that text file is just going to be this SCB text. So we'll just execute that one. Yes. Right. So now we've spooled that out to a text file. We'll just jump into that directory, and we'll pull up that text file. So what we'll have at the end of these records is days since last order. Now, in this particular example, there isn't a lot. There's a lot of new customers. So as we scroll down, you can see that there's only a few records that have actually got previous orders in the system. So I'll just go back to where we were. So that's a state-based calculation, just to simply find the number of days between the current order and the previous order that the customer made. The next pattern that we're going to look at is going to be transactional loading. Now, with transactional loading, you're trying to define how to ensure a consistent state of your data while loading, and how to ensure that you can roll back all your changes if the load crashes. There are 4 common patterns for managing transactional loading. Database managed, which is where you allow the database to manage all the transactions that you're running in a particular transformation. And if any of them fail, the database is responsible for rolling back the transactions. The next one is to use a swap table, which is the example that we're going to go through. The swap table is basically populate the data into a separate table. Once it's populated, delete the actual fact table that you normally have and replace it with the staging table that you've built. The next one is a dirty flag. Now, a dirty flag is simply putting a flag on your record similar to that deleted flag that we were indicating before, that allows you to find out whether the data in the system is of a clean state. And a lot of these can also be built together or put together with batch IDs from your batch processing pattern to also give you other ways to roll back if transactions fail, so you can delete all records where a batch ID equals a certain value. So we're going to have a look at the swapping tables around. So we'll just hide that so that you can see the screen a bit better. So we're doing this inside of a job rather than a transformation. So we're starting off with our common start point, and the first thing that we're going to do is check to see whether the staging table that we're going to populate from actually exists. If it doesn't exist, then we're going to have to go in there and create the table. So it's just a simple create statement. If it does exist, then we're just going to simply go in there and truncate the table. Once we've done either of those two processes, we're going to run the execute batch processing transformation that we built previously. So that's this one. And then we're going to check whether the sales table exists, so the fact table. Now, in normal processing, you wouldn't expect that fact table to be missing. However, if something horrid goes wrong and you drop the table and you can't, and something goes wrong swapping the previous table in, etc., putting in this check feature before you actually go and drop the sales table will ensure that you can always swap the staging table back into the sales table. And these are quite simply a alter table statement to rename it and a drop table statement. So we're dropping the sales table and then we're altering the name of the staging sales table to sales. And that's the end of the process. Now, often at the end of this point, I would be looking at putting some post-processing in here, like building indexes, refreshing Mondrian cache if this is going into an OLAP engine, etc. So if we just go and run this, yes. So we can see that it finished successfully, and what we should see at the end of it is that we only end up with one table in our database. We don't have the staging table anymore because the staging table has been renamed at the end of the process. So we come back into here. So we've only got our sales table. If we do a preview, we can certainly see there's rows in it. Okay. Now the last pattern that we're going to have a look at is for loops. Now, what I'm going to show you doesn't actually implement a loop because looping is in general a very bad thing to do with inside of an ETL. Jobs do support looping. Transformations do not support looping because all steps inside a transformation are executed in parallel, whereas in a job they're executed sequentially. The other issue that you have is if you do implement looping inside of a job, eventually you'll get a Stack Overflow error within inside your Java virtual machine. Now this is because of the way that the underlying Pentaho engine is developed. Now that Stack Overflow error may take a day to happen, may take a week, may even take a month, but it's a very hard problem to debug at the end of the exercise. So the solutions for this particular pattern is to either one, externalize the loop, either in the operating system or in Pentaho Data Integration server using the scheduler, or put some logic in the system to break after a set number of iterations inside the loop. So I'm going to show you an example that would be used if you were trying to externalize the VE job inside of the data integration server or the operating system loop. The important part here is that we're going to create a locking file. So that locking file is going to tell the job whether it's allowed to proceed or not. The concept here is if you're looping and the loop normally takes a minute to run, and for some reason you get a larger file in or a lot of load on your machine and it takes a minute and 10 seconds, you don't want the process to start up again until the previous one has completed fully. So what we're going to do is, first and foremost, check if the locking file exists. If the locking file does exist, we're just going to abort the job based on the fact that a previous instance of the job is running. If the locking file doesn't exist, we're going to go in there and create the locking file. So this then tells the system that this is the only version of this job that's going to be running. I'm going to go in and execute the swap table job that we were just looking at before. At the end of that process, if it finishes successfully, we're going to go and delete the job, delete the locking file and successfully complete. So as I said, the concept here is we would schedule this into the data integration server to run every minute, 30 seconds, 5 minutes, whatever the period is that you want the checks to be, and you can get it to as near real time as you'd like, and use this locking file to determine what's going to be, whether the next time cycle can run. So we'll just go and execute this. It's not very exciting, but we'll just execute it. Now, interestingly enough, it says that the locking file here didn't exist, so it went through and it's successfully completed. So we can just follow the ticks through the system, and it successfully did the job and it's deleted the locking file. So if we go back here, we don't have a locking file here. If we wanted to have some fun, we could say create new empty document, and I'm going to call it no loops.lock. Now that's what I've called the locking file within inside the system here, no loops.lock. And what should happen now is if I run that, it's finished as a failure, mostly because I've told it to go to an abort step. You don't have to set it to go to failure. You could say that that's still a successful run, but it highlights it quite nicely within inside here. Now, as I was sort of mentioned earlier in the piece, there's also common patterns around pre and post processing. So creating this lock file and deleting the lock file is common examples of pre and post processing. Other examples would be creating the batch IDs, as we mentioned previously. Creating statistics for creating job statistics would be a post job. Inside of an actual individual transformation or sub-job, you might be looking at dropping indexes prior to loading data, because indexes usually slow down loading of large amounts of data. And then the post for that would be to actually go and rebuild the indexes. Another example of a post-processing would be building aggregate tables.